Hello and welcome back to Chef Fundamentals and Recipe Writing. This is section 4 of this video series. In this we are going to talk about chef internals. So let's take a look at what exactly we are going to learn in this section. First of all, we will take a look at what exactly a node object is and what Ohai is and how they are interrelated. Then we will see how to use search in chef and what exactly it is used for. And finally, in the third and the last video of this section, we will see what are the different files associated with chef and how to work with the security files and the configuration files, where are they located and what is their usage. This is the first video of this section in which we are going to talk about node object and Ohai. Now, Ohai is a chef profiler. We'll take a look at what exactly a profiler is. Before we understand a node object and Ohai, let's first try and understand what exactly is an attribute. Attribute is a special detail about a node, such as an IP address, a host name, a list of loaded kernel modules, the versions of available programming languages that are available, and so on. It is unique to a specific node, or it can be identical across every node in the organization. For example, if you have 10 different nodes and if all of them are Red Hat machines, then of course the platform will always mention Red Hat for all these machines. And let's say if you have 5 Red Hat machines and 5 Ubuntu machines, then the platform family for 5 of them will be Red Hat and for other 5 of them will be Debian. Now, attributes are most commonly set from a cookbook. You can use knife and you can retrieve the Ohai attributes from each node prior to every chef client run. And all attributes are then indexed for search on the chef server. So in a nutshell, attributes is nothing but individual properties of a node. And as we have seen, it can be anything. It can be an IP address, it can be a host name, it can be the IPv6 address, it can be the platform, it can be the CPU, it can be the architecture, anything. All of these individual components of a node, you can call them as individual attributes. So now let's try and understand what exactly is Ohai. Ohai is a tool that is used to detect attributes on a node and then provide these attributes to the chef client at the start of every chef client run. Ohai is required by the chef client and must be present on a node. Typically, Ohai is installed on a node as part of the chef client install process, and chef client installation takes place during node bootstrapping. The types of attributes Ohai collects include platform details, network usage, memory usage, CPU, kernel, host names, fully qualified domain names, and a lot of other configuration details. But they're not limited to this. You have a lot more attributes than the list on a screen. Now let's take a look at how exactly attributes look like. If you see on screen, this is a screenshot taken from Chef Server UI. And once you select a node, on the bottom half of the screen, if you click on attributes, you have all the attributes listed, which is nothing but the node object of that node. During every chef client run, the chef client builds the attributes, and that list is built using the data about the node collected by Ohai, the node object that was saved in the chef server at the end of the previous chef client run, and the rebuilt node object from the current chef client run after it is updated for changes to cookbooks, roles, environments, and updates for any changes to the state of the node itself. Now, after the node object is rebuilt, all of the attributes are compared and then the node is updated based on the attribute precedence. At the end of every chef client run, the node object that defines the current state of the node is uploaded to the chef server so that it can be indexed for search. Now, how do we check the attributes of a node? We have multiple ways actually, depending on where we are searching the attributes. If we are on Chef Server GUI, we have a way, which we just saw in the previous screenshot. We will take a look at it again. Then from the Chef workstation, we have a command called knife node show, through which we can check all the details of a specific node. And if you're on the Chef node, then we have this Ohai utility, which helps us see the node attributes. So here I am on my chef node, which is node 2, and here I am on the chef server GUI, and as you can see, I have my nodes listed on a screen. Now let's say I click on node 2, and on the bottom half, if I click on attributes, this is where you can see all the attributes listed, and this is what as a whole is known as a node object. If you see here, I have all the kernel related information, all the network related information, including the IP and other details. And if I scroll down, I have the CPU related information, file system, then I have memory. So all the details you can find over here. So now let's take a look how exactly we check the node attributes on the workstation. So I am on the workstation now. First of all, let's do a knife node list to get the list of the nodes. So we have node 1 and node 2, just like what we saw on our Chef GUI. Now let's say I once again want to check the attributes of node 2. So I need to do a knife node show node 2, which is the name of the node. Hit enter. So this list is a very concise list where I have only about 7-8 details about that node. Let's say I want to get the full details or the full list of the attributes which are associated with that node. I do a knife node show node 2 space -L. Hit enter. And it gives me a lot more detailed list of the attributes which are associated with that node. Now, if I want to check how many of them are there, let's do a word count. And if I check the number of lines, I have 1433 lines for this node object. So typically if I take per property 2 lines, then still I have more than 700 properties listed for this node. Now the same thing if I want to check on my node. This is my node 2. And if I do a Ohai, it gives me the list of attributes, and I can simply keep going and I will get all the details about the node. Now let's say if I want to check the number of lines here as well. This time it is 1894 for the same node. The main reason for the difference in the number of lines is because of the format, how it is being used. In this format, I have almost one property in each line. But in this case, as you can see in the output, if I show this once again, as you can see, I have this in a nested format, which looks more like a JSON format. So that is the reason I have different number of lines when it comes to the node. And for the same node, if I check the attributes from the workstation with the help of knife commands. So that's how you check the details or check the node attributes from different places. So now let's take a look at how exactly you can use the attributes inside a recipe. So as we have seen that we have all the possible things listed in the form of node attributes. Now, if you remember, this is one of the recipes which we have written to install Apache on our nodes in one of our earlier videos. Now, in this example, the name of the package is HTTPD. So we are assuming that this recipe is going to run on a Red Hat family. Now, if you run the same recipe in an Ubuntu server, it is going to fail because the name of the package for Apache on an Ubuntu node is Apache 2, which holds true for all the Debian family members, be it Ubuntu, be it SUSE, or the Debian OS itself. So now we have two options. We can either write two different recipes for each Red Hat family, which will contain the package name as HTTPD, and another recipe which will contain the name as Apache 2 for the package, which we will run on the Debian family. Or we can write a single recipe, and what we can do is we can make use of the platform attribute. Let's take a look. So this is the name of the package, install Apache, and we put a case here. We will create a case construct in which we are going to use the platform attribute from each node. And if you see here, what we are writing is when the platform is Red Hat or CentOS, package underscore name is HTTPD. Whereas if the platform is Ubuntu or Debian, then the package name is Apache 2, and then end. So the second recipe is going to work on both Debian family as well as Red Hat family.